study the universe, its history and contents, scientists use whatever possible to capture and analyze light. The eye is the most popular instrument for astronomy. When we look up into the sky, our eyes receive light and send it to our brain. Unfortunately, our eyes can only view the brighter objects in the sky. The early astronomers mapped out an atlas of what they thought to be the universe. They charted the motions of some planets and stars, but hardly had any idea of the universe we know today. On clear nights in the winter of 1609, Italian scientist Galileo Galilei pointed a strange object into the stars. Gazing through two lenses attached to opposite ends of a tube, Galileo forever transformed the world of astronomy. Nearly 400 years later, the science of astronomy was on the brink of another technological leap, one that promises to change our view of the universe again. This time, the leap was not the result of one individual, but of thousands. Over the past few decades, we have struggled to see beyond our atmosphere. Even from mountaintop observatories, our view of the universe is blurred. And because the atmosphere absorbs certain forms of energy, our knowledge of the universe has been limited. In the late 60s and 70s, NASA launched a series of special-purpose observatories revealing energy from all over the electromagnetic spectrum. These satellites witness new and old stars never seen before, encouraging astronomers to move on to larger observatories. With the birth of the space shuttle, NASA had the means to carry a large telescope into orbit that was comparable to some of the best telescopes on the ground. Until now, advances in telescope technology have occurred in small steps with larger mirrors, higher sensitivity, and more definition. But by placing a telescope above the atmosphere, the image would be 10 times sharper than that on the ground. With all this technology in hand, NASA gave birth to 4 great observatories. Since objects in the universe radiate at different wavelengths depending upon how cold or hot they are, scientists need a collection of telescopes to see each of the major bands of light: gamma ray, X-ray, visible light, and infrared. By adding together the observations of 4 telescopes, a complete picture of the universe is formed.
The universe that we all live in is incredibly vast. It is also very dynamic and violent, and the processes that are ongoing emit energies beyond and below the visible spectrum. And only the visible part of that activity can be seen by ground-based telescopes because the Earth's atmosphere, fortunately for Earthlings, absorbs that energy. And the only way to access it is to be above the Earth's atmosphere. And that's the thrust of the great observatories.
The first of NASA's great observatories is the Hubble Space Telescope, which receives light in the visible light spectrum. The Hubble telescope was designed to be as large as possible while still being able to fit inside the space shuttle. At the heart of the telescope is an 8-foot mirror, giving Hubble the power to see objects 10 billion light years away.
The Hubble Space Telescope, one of its premier projects was to measure much more accurately the so-called Hubble constant. And this is the relationship between distance away of a galaxy and its velocity. What Hubble showed was that the further away a galaxy is, the faster it's moving. And if you think about it, that slope of that line, how fast things are depending on how far away they are, tells you how long they've been going. If you run it backwards in time, all the galaxies were together in one spot. So by measuring this slope, we'll know the age of the universe.
The Hubble telescope is equipped with a state-of-the-art tracking guide. By drawing off a catalog of 15 million stars, the Hubble finds a target, then locks onto 2 guide stars with 2 of its 3 sensors. The sensors detect any drift and correct the telescope's position.
If you were to take a laser in Washington and aim it at New York City with an accuracy and stability of 7 milliarc seconds, you could have a person stand on the World Trade Center and hold a dime, and that laser would never depart from that dime. And this is with a device that's very large, weighs about 24,000 pounds, has wheels spinning, has motors moving, antennas churning. With all this activity, this device will still point to any place in space with that precision.
The Hubble telescope was launched in April of 1990 by the shuttle Discovery and is currently in orbit awaiting adjustment and repairs.
NASA quickly commissioned a repair mission dubbed CoStar, which will be flown in the December 1993 launch, which will replace one science instrument with this CoStar module and will correct the spherical aberration, and it will be able to meet all of its initial scientific goals. It will be able to see to the edge of the universe.
The gamma ray and X-ray telescopes will witness the more violent side of the universe. Hot matter in the universe, such as quasars and pulsars, emit energy of the shortest wavelength and highest energy. Since our atmosphere blocks gamma rays and X-rays, the field of high-energy astronomy is only 30 years old.
Well, I think there's been a steady progression of X-ray experiments, more and more sophisticated detectors and optics. The last major American mission was the Einstein Observatory.
The difference between AXAF and its predecessor is its size, technology, and image quality, which will be able to observe objects 15 billion light-years away.
One of the interesting areas that astronomers would like to know about is the very beginnings of our universe. And this means that fortunately we have a way of doing that, is observe things that are very far away. That means that the light has taken a long time to travel here. It means that we're observing what they were like in the past.
Currently, engineers are working here in Rochester to build the precise mirror assembly.
The most difficult part of AXAF is the fabrication of the very special grazing incidence optics. And these are the only optics that can form images of X-ray energy. Those optics are precise to a few millionths of an inch. And our challenge on AXAF at Kodak is to develop a mount that will hold these optics essentially strain-free and in nearly perfect alignment through the transportation and the launch environment.
The infrared telescope should complete our view of the universe by observing the colder and newer objects in the sky.
The infrared region is of particular interest because it corresponds to things that are at colder temperatures. For instance, one of the fields that I think just about every infrared astronomer becomes interested in is star formation. We wonder how the stars formed. It's been said that if stars were not observed, the theorists would never have predicted the stars. It's a great mystery.
Because we cannot yet venture into the far reaches of space, we have to explore by collecting light. With the 4 great observatories, we'll have the opportunity to see and know more about the universe. These observatories, perhaps more than any other, appeal to our imagination with the promise of new discoveries, spectacular images, and the answers to the most intriguing questions.